meet any environmental regulations. I hope that soon I'll be able to also present in Indonesia. This is my first time on Java Island and I've had a great time. And I'm still learning Indonesian, but hopefully in the future I'll be able to be as fluent as yourself and everyone else. Yes, like Francisco, yes. And that was really good. But unfortunately, I'm not as fluent yet, so I will present in English. I hope that's okay. But yes. So first of all, thanks everyone for having me here. Thank you for the great presentation of the monument as well. It was very impressive. Thanks always to Brin for being very accommodating. So I'm Ramon Skane. I'm the Director of Sustainability and Operations at Continuum Energy. And in the time that we have, I will present two main technologies we're pioneering at the moment. The first being eco-fuel, which is a combination of the good and also geopolymers, which I discussed with Donny, the architect, which I think would be a good potential collaboration for the monument too. Anyway, so just change some technologies to waste energy and refuse, along with our scale-up trial in Thailand, the goals and objectives, the results, and the environmental aspects as well. And then I'll look into eco-concrete, which is this geopolymer concrete I was discussing with Donny before. So first of all, this is just the executive team of Continuum Energy. We are a group of different companies from around Australia and Southeast Asia, and we are looking at engineering project development focusing on renewable energy and circular economy. So everything's sustainability. And our main goal is to invest in projects that have renewable energy and circular economy both, if we can. Because renewable energy is very important, but there's also circular economy. There's two problems we have to deal with. So we look into we do engineering projects, and we also do project investment too. So the team has over 100 years combined experience in waste management, power generation, civil and construction. So the team has worked on 350 megawatt wind farms in South Australia. Some of the team has also worked on weird projects like dams. Some of the team has worked in, I've worked in hydropower in Western Australia. I'll continue just for time. But essentially our values and mission, again, it's all about sustainability, climate change, and circular economy. And again, we want to promote solutions with renewable energy and circular economy both if we can. Along with, not just the engineering side, but also the social side and the economic side. The social side, so the people accept it and they enjoy it. The one thing I really love about your presentation is the strong focus on culture. And I really appreciate that. And we're also focusing on the economic side as well, so that it can actually be long term. And it can be a truly sustainable solution. So just a sort of background to my stand, it's easier to no, I can. In Australia, we usually stand when we speak. Sorry. So just a sort of background on circular economy and renewable industry. I'm sure a lot of you are already familiar. So the world generates over 2.1 billion tonnes of municipal solid waste per year. That's a conservative amount. It's actually much more than that. It's expected to grow to over 3.5 billions of tonnes per year by 2050. And again, this is conservative. It's much more than this amount. Most waste is sustainable solutions. There's been lots of technologies we've seen that have tried dealing with this, such as waste to energy, such as refuse-derived fuel, and they've been tried different times around different countries, and like every technology has challenges, so there's always some issues that need to be dealt with, but the main technology we're pioneering for this first part, eco-fuel, is a combination of waste to energy and refuse-derived fuel. So a lot of greenhouse gas emissions. So even when the landfill is just sitting there doing nothing, you have chemical reactions happening and gases coming up all the time, right? Especially with sanitary landfills where you get significantly more methane. So for those of you unaware, methane can be 20 to 30 times worse than carbon dioxide. Now this leads to air pollution, greenhouse gas generation. You also have mismanaged waste materials. So sometimes, like I've been to landfills in India, and we've had farmers, because the education on waste isn't as well where I was, and farmers would dump all hazardous waste matters into the landfill and it would putrefy all the water system. So they've been drinking from this particular lake for about 1,000 years, and then 10 years ago a farmer put hazardous waste in it and no one's drinking it from since. Issues as well, soil contamination. Pioneer is ecofuel. So this is a modern approach to renewable energy and circular economy combined. It takes the good from waste energy and the good from refuse-derived fuel. It can be made from fresh municipal waste, household waste, and it can also be made from in-situ landfill waste. So both. It has a renewable capacity and potentially carbon neutrality, which I'll go into eventually too. And one good part about ecofuel is that it's a reflection on how waste is being managed. Because when you make this refuse-derived fuel, you get a lot of data on what the waste actually is, and so from that you can improve too. So just to sort of show how the process works. So first we go to the people and we say, we do assessments of what waste they're generating, how much they're generating, and we get involved with the people at the local community level. Now what usually happens is they usually generate waste and send it to landfill. Our idea is to have our ecofuel facility at the landfill, make it into ecofuel, which can replace fossil fuels and also divert waste. This can be made into sustainable electricity, and then that electricity is used by the people again. So as I mentioned, we can use fresh and landfill material, which I'll show as well. This is a landfill in Thailand we were working with. It's an environmentally friendly alternative fuel, which can replace or partially replace fossil fuels, and it can also return landfill sites to for land development. Process diagram. So we get the landfill material, we literally scoop it up with this big digger. Scoop the landfill up, put it in our facility, and we separate the inorganic materials, which become recyclable, which diggers can get. So you have metals in here, you have metals, you have rubbers, you have tires, everything. We directly separate that for people to use, and the organics we process, quality control, and make our ecofuel according to all environmental regulations. So our ecofuel meets international US EPA meets any environmental regulation of waste. So we know exactly what we're dealing with, and we can improve on it if need be. We can also correspond with local stakeholders on the community level and how to, with feedback from this waste analysis, on how they can improve their waste processing and their waste management. So again, we did some tests on this, and we found that it was feasible. And this is independent laboratory documentation we've had done in Thailand. So just to sort of compare, without getting too much into the engineering detail, so the regular coal that we're burning is about, say Indonesian coal they actually burn, is about 4,500 kilocalories per kilogram. We got about 4,700. The conventional RDF there at the moment, this is another company which I'm not allowed to mention, but they're getting 3,000, so very low. And they're also polluting the environment very badly, which we're trying to tell. So one thing, we also wanted to see how high we could get this energy value. Because the higher the value, more economic the process, the more waste is used, and the more waste is free of the landfill. That's our main motivation here, to get rid of as much waste as possible. And so we found that we could also get an RDF ecofuel up to 6,400 kilocalories per kilogram. So this is usually unheard of. This is one of the reasons which separates ecofuel from RDF, because we have a very complex, thorough analysis of our waste, which can get to these levels. We also did assessments on the pollutants. So the regulation in Thailand we were supposed to meet had a chloride weight percent of 0.6. I believe in Indonesia it's between 0.3 to 0.4, and we had ours at 0.13, so very low. And the reason we did that again is to show, because when you're dealing with waste, and I'm sure you can relate to the monument, people think it's dirty, people think it's not clean, and they don't want to work with it. We wanted to show that it can be a waste can be transformed into a usable product. And by doing that, we've shown that it can be environmentally friendly too. We also, when it comes to combusting the ecofuel material in cement kiln or power station, we also communicate with those off-takers to ensure that when it is combusted, it is safe, and we do analysis of the smokestacks, everything as well, to be sure that it is. The people can use it easier. And for now, but this, just for curiosity, any of those in the engineering science who are curious, this is what it looks like under the microscope. So this is cold fly ash, and we got the fly ash, mixed our chemicals in it, and it degrades the skin of the sphere, and then from that you have this build-up of material, and eventually all this material build up and then come together, and then that forms the strong concrete. Quickly, so just to sort of summarize, this all sounds good, but why geopolymer? And the idea is because when you have concrete, which is the most manufactured product in the world that uses no waste and has so much emissions, we can have a concrete product that can be made with 80% less emissions and use a significant amount of waste. It can be made for seawalls, it can be made for concrete panels, concrete blocks,